Hello everyone, I welcome you once again into today's lecture. My name again is John Sekajugo, a lecturer in the Faculty of Agriculture and Environmental Sciences, Mountains of the Moon University, and your facilitator for this course, GIS and Remote Sensing. So in our last lecture, we looked at how to import data into the GIS environment, into quantum GIS specifically. We looked at how you can be able to change the display formalities, changing the symbology and naming. And today's video, we want to continue from there and see how you can be able to do other manipulations, other operations. For example, if you have the data, if you have a map of Uganda in the districts, how do you pick out the district of interest? For example, what we call clipping. How do you clip out the district of interest, assuming it is your study area? You want to pick it out from the entire Uganda map. How do you do that? So if we want to continue from the previous project, I can just go under project, and instead of now saving, I say open, and then I look for that particular project that I saved, and you can see here it is MS Agroecology, and then open that particular project. You see, it will come direct from where we saved it. Now we have these maps. For example, if you want to select, for example, in this case, we are going to use Kasese, Bundibujo, Bunyangabo, and Kabalole as examples. If you want to select these districts from this whole map, how do you do it? Now, there are several kinds or several ways in which you can be able to select. But for what we are going to use, if you move your cursor under the toolbar, for example, there is here what we call select features by area or single click. There is select features. Now, when you select, you click on select features. Now you see the cursor now has a rectangle on it. So this cursor helps you to select the districts of interest, for example, or the places of interest. And while controlling or selecting that control, we are going to select the areas of interest. And here I've said we are going to use Bundibujo, Kabarole, Bunyangabo, and Kasese as examples. So I click on Kasese, you see it will be highlighted. Now it is yellow. I click on Bunyangabo while it's pressing control, Kabarole, and Bundibujo district. Now you see these ones have been selected from the rest, and that's why they are yellow. Now, once you have selected these, you can now save them as a separate layer. And that's how you can also be able to create a new layer from the existing layer. Now, you can be able to save these ones and then pick them out from the rest of the districts. And how do you do that? Still, you go and highlight this particular layer under the layers panel, right click. Now, you click on export. When you go on export, there is another display, this small one that is here, and there are different functions. There is save features as. Now, when you save features as, you will save this layer again, this main map of the Ugandan districts. But we want to save the selected features only. So save selected features as, because we want to save these selected or these maps or these districts that we have highlighted or that we have selected. Save selected features. When you click there, another window will pop up here. Now, this window has the first word here is format. And here by default is S3 shapefile, because we said vector layers are saved as shape files. Now, sometimes there could be different like GEO package, but you have to make sure that S3 shapefile is the selected format, or the format of interest, the format in which you want to save your data is the selected one. And the file name here now, you have to select or to give your layer that you want to save a file name. And how you do it is to browse to where you want to save your file. And for me, I will save it under data, and I'm going to give it a file name. You can name it the way you want, but here I'm going to call it study districts. Now, once I've given it the name, I will say save. Now, there is also the CRS, which stands for Coordinate Reference System. So, which coordinate reference system do I want to give my layers? For you can either leave it as the World Geodetic System, which is WGS 84, or you can change the reference system to a customized system. For example, here I know the one for Uganda is under zone 34, so we use the WS 84 UTM zone 34 as the reference system. I can select that and say OK. So once I'm very happy with this, there is always this other part, save only selected features, make sure it is checked. And once I'm very happy, I will say OK. So when I say OK, you see now the districts we selected are highlighted, or they are saved. And under the layers panel, we no longer have only the Ugandan map only, we also have the study district layer that we have just saved. Remember, we selected the 4 districts and now we have saved them. So assuming this was your study area, you have already finished creating your study area or selecting it from the rest. If you are no longer interested in the Uganda district, you can uncheck it. If you uncheck it, you remain with only now the new saved districts or the selected districts. That's how you can select and save the data of interest or the area of interest from the bigger area. So this is how you can do it. And you can always put back at the Uganda district, or you can remove it completely, assuming you no longer want it. How you do it, you just right click and say remove, or click on it as we said, and click on remove. And when you click on remove, it will ask you and you'll be able to remove it. So you can also display this, and you can rename, or you can rename these districts from the process or the same procedure that we saw last time. By going to the layer, right click, go to properties, and remember we said if you want to change the display, you can go under symbology, and instead of simple fill, we said you click on it and look for outline simple. This one I will click OK, it will change. And we said if you want to label, you click on labels, and instead of no labels, you click on single label. And here I want to use also district 2020, and I will say OK. So when you say OK, you see the districts Kasese, Bunyangabo, Kabarole, and Bundibujo. So here you can be able to reduce or downscale the data from a bigger data set to a lower one. You can be able to select the areas of interest that you are interested in working with. Now, it is also possible to clip the data of interest using an existing boundary layer, for example. Assuming I wanted to clip to get the roads in Kasese district only, for example. If I wanted to get the roads in Kasese district alone, for example, I would use Kasese district layer and clip out the roads in Kasese from a bigger road layer. So if I want, for example, here to clip or to get the roads of Kasese, the first thing is to add the layer of roads, as we said. And how you do add the layer of roads? We said roads can also be stored as polygons. So we go to under add vector data, and now this time we are going to look for roads. Here under the layer of roads, which are get here, and then here I look for the shapefile of roads, and then add it. So when I import it, you see you have the district, you have the roads for Uganda. But remember, I'm interested in the roads that are in these areas of interest. Now, when you want to do that, you can do that by clipping. You use the function called clipping. Clipping is like you want to grasp, hold, and clip the layers together or something together. So we can use the clip function to select the roads that are in these particular districts from the Uganda roads. How do you do that? We can go, remember these are vector layers, so we are going to use the vector operations. You go under vector, and under vector you go to GEO processing tools, vector, then GEO processing tools, then clip. Now when you click on clip, it asks you what is the input layer. Now the input layer in this case will be the layer from which you want to pick data, and will be the UNRA road layer. Now that is the input layer. Now the overlay layer is now our study districts. Study districts, we select it. Now the clipped layer, in that case will be now the new layer of roads. And here you can save the clipped layer, or you may not save it. If you are going to work with it, you have to save it to where you are working from. And here I will not save it, I will leave it to be saved under the temporary file. And once I've selected those ones, I would say run. So when I say run, you see there is a clipped layer now. Now that clipped layer are the roads in this particular district. And to show you that if I deactivate the UNRWA roads for Uganda, you see now we have the roads in the districts. Each district now has the roads, and we can change also the display of these roads like we have been doing it under properties, symbology. Instead of this color, we can change the brown to the brown color or the color of roads. Apply, you see, and those are the roads in these districts. We have done this through the clipping function. Okay, so you can clip and manipulate different data sets, use different functions to manipulate the data. The only thing you need is to keep practicing and explore these icons that are within your GIS environment and learn how to use them. I can tell you GIS is about practice. If you don't practice, you will not learn. So you can explore different icons and see how to use them. What I advise you is really to keep practicing with your GIS softwares. Of course, we have been looking at how to import data, the vector data, and manipulate it. We haven't looked at how to import raster data and manipulate it. So in this very lecture, I want us to move away from vector data and importing vector data and manipulating it to how to import now to add raster data to the GIS environment. Like we have been adding vector data using the add vector layer icons, we are going to use the add raster data to add raster data or images or maps into the GIS environment. So to add the raster data, we are going to go to add raster layer, and then I will also browse like we have been browsing for vector data to the directory where we have saved the data, and here I saved it under also the data, and here I have images, different images, and what I'm going to use now here is the NDVI image. The NDVI is for normalized difference vegetation index that we shall work with, but you can work with this. If I open it, you see there are different images, and I'm going to add this, of course, as a TIFF file. Of course, it's a TIFF format. I'm going to add it to the GIS, and when I add it, you see now the image is added into our GIS environment. You can be able, of course, to rotate it, and if you are familiar with your particular area, you see Uganda is here, and there is Lake Victoria and the rest. Now, it is also possible to display. It is also possible to display vector data and raster data together, of course. For example, you have added this image. Assuming your area of interest is not the whole of this image, which is representing the whole of Africa. Maybe you are interested in studying the data or the NDVI or the vegetation index of, for example, Kasese, Kabarole, Bunyangabo, and the individual districts only. It is possible now to use the vector layer or the vector layer of the area of interest to clip out, to pick out the area of interest from the image that you have just added. It is possible for us now to pick out the area of interest, the Kasese, Bunyangabo, Kabarole, and the individual area from this bigger area of interest. And we do that also through clipping. For example, if we want to do that, I'm going to add the study area, which is the Kasese, Kabarole, and Bunyangabo district maps on this area. You see, you can overlay. We call it overlaying. Putting one layer on top of the other. You can overlay the district boundary map on top of the image map. And we can use this map, the district, the overlaid layer, to clip out the area of interest. How do you do that? We are going to see how to do that. If I remove the labels, we can be able to see how to do that. We want now to clip the area of interest from this bigger one. You can do that first of all either by going to raster, because we are now operating the raster layer, and under extraction, so clip raster by mask layer. Remember, we want to clip out or to mask the out the area of interest from the image using our boundary layer. So you go to raster, because now the image is a raster layer. You go to extraction and then clip raster by mask layer. Now the input will be our NDVI map, which is the raster map, will be the input layer. And the mask layer now will be the district of interest. It asks you to pick the source, which is optional, the source coordinate reference system, which is optional, and the target coordinate reference system, which is optional. But in this case, of course, I can specify it, assuming I don't want it to be optional, and I give it, for example, this map. And then you will say run. Once you have selected the layers, run. Okay? Now, if you say run, you see we have clipped out this area from the main. Of course, it has this extent out, which is not of interest, and we can always reduce that. But you see, we have clipped out, we have selected out the area of interest from the bigger map. We can also do that by through another format. Instead of using going under raster and then clip by mask, we can go under the tool, okay? The toolbox, you see this icon, toolbox. So this toolbox, it allows you to do different operations. So if we go under toolbox and we go to under raster analysis, for example, raster analysis, it is also possible to do the clipping, okay? You can do the clipping, or if you are not finding it, the easiest here is to type clip, and then you see clip raster by mask layer, or clip raster by extent. You can also clip by other options, okay? There is also under the Saga, the Saga gives you other options where you can clip, of course, by points with polygons or other things. So you can still go under this particular operation and do what we have just done, okay? So with that, you can also be able to manipulate raster data. You can even also be able to change the display of these raster data. For example, under this, if we go under properties and under symbology, instead of single band gray that is here, we can click there and change. Instead we say single band pseudo color or pseudo color, okay? And under interpolations linear, under color lamp, we can select the color for which you want to use. For example, I can select spectral here, but you can select other options. And once you have done that, you can say apply or OK, and the image will be now displayed in different colors. Now you see, you have beautified it, and now it is displayed in different colors. It's like you have classified the image into different colors. Instead of displaying it as a single band, a gray color, you can display it in different colors, okay? And you can change colors also. Instead of, for example, here we know this is water. Instead of being brown, we know water is always displayed with a blue color. We can change the colors. For example, under properties we have been, for example, instead of 0, which we know is the water, instead of being blue, we can say no, we want the blue, the red, instead to be the one which is blue. We say OK, and we want it to increase from blue going upwards, for example. We can say, OK, this one can be that, and then this can leave it. And now the last one, which will be now the high vegetation, instead of being blue, we make it dark, very green, and we say apply. And you see, it changes. Instead of now the water being red, now the water is blue. And with that, you can be able also to manipulate and work with raster data in different kinds. So what I want to employ is really again to practice. Keep adding different data layers, keep adding different vector or images, practice with different icons, try to change the colors, the symbologies, try to name the data, do the clipping, so that you can familiarize yourself with how to manipulate different data formats within the quantum GIS environment. With this, I want to conclude our lecture at this, and thank you very much.